We often don't give a second thought to the water flowing from our taps, but lately there's been a lot of reevaluation happening, even around something as common as fluoride.
Exactly. And that's really what we're digging into today. You sent us some fascinating material about a recent Health Canada expert panel meeting. And, well, we're going to unpack their discussion on the health effects of fluoride in drinking water.
Yeah, our mission here is to take those sources you shared and really try to get to the core of what this panel concluded and, what it could mean for how we think about the water we drink every day.
And just for context, it helps to know that Health Canada is the body responsible for setting the guidelines for Canadian drinking water quality.
Right.
They keep an eye on different chemicals, and fluoride, well, given its potential to affect our health, it was prioritized for a fresh look.
And the current guideline, that's been around since 2010, right?
Yeah.
It sets the limit for fluoride at 1.5 milligrams per liter.
That's the one.
But, as new science comes out, it seems vital to go back and check if those guidelines are still, reflecting the latest understanding.
Absolutely. So Health Canada convened a panel, 6 independent experts. Their task was basically to thoroughly examine the scientific evidence,
Okay.
looking at how we're exposed to fluoride, its connection to dental fluorosis, and crucially, any potential impact on children's brain development, their neurocognitive health. And ultimately, they were asked to provide science-based recommendations for what's called a health-based value for fluoride in drinking water. So essentially, what level is considered safe based on the science?
Okay, let's unpack this. So just so we're super clear for everyone listening, we're not getting into whether fluoride is good or bad overall, or like the debate about water fluoridation itself.
No, not the benefits or risk management side.
This deep dive is specifically about how this expert group looked at the science around how much fluoride we get, what it does to teeth, if it has any impact on the brain, and how they tried to figure out a safe level based only on that health science.
Precisely. The panel's focus was squarely on those potential health considerations linked to fluoride exposure. They were building a scientific foundation for Health Canada to use as they think about maybe updating those drinking water guidelines.
All right, so let's start with where this fluoride is coming from. What did the panel conclude about how we're all, getting exposed to it day to day?
Well, the panel's assessment pointed to 2 main pathways for most people. First, drinking water, and that's not just water from the tap.
Right, it includes like pop made with tap water
Okay.
or food.
Exactly. Beverages, food prepared with fluoridated water, that all counts.
Yeah.
And the second big one is dental products. Think toothpaste, mouthwash.
Okay, so it's really about what we swallow and what we use in our mouths.
Pretty much, yeah. Those are the key routes.
We definitely hear a lot about fluoride in toothpaste. But what about other things like the air we breathe or maybe the soil? Are those significant sources?
So according to the panel, for this particular review, looking at the general population, air and soil aren't considered major players in our overall fluoride intake.
Gotcha.
The focus is really on what we ingest through water and those oral hygiene products.
Okay. Now, I saw this term pop up in the materials you sent. Allocation factor. What's that all about? How did the panel use that?
Yeah, the allocation factor. That's a really important piece of the puzzle. You can think of it as an estimate. It tries to figure out how much of our total fluoride exposure comes specifically from drinking water.
Okay.
And they focus particularly on the individuals who might be most sensitive to any potential effects. It's basically a way to account for the fact that we're not just getting fluoride from the tap when setting a guideline for that tap water.
Okay, so it's like figuring out how much of the, let's say, fluoride budget comes from drinking water versus other things like toothpaste.
Exactly. You've got this total exposure, and the allocation factor represents the slice of that pie that's attributed to drinking water for the risk assessment.
So what did the experts decide on for this factor? What slice did they assign to water?
They actually reached a consensus on an allocation factor of 0.5, or 50%.
Half. Okay. Why half?
Their reasoning was that, based on the available data, both drinking water and dental products are pretty significant sources of fluoride exposure, especially for young children. So they decided to give them equal weight when figuring out that health-based value.
So they're essentially saying, for the purpose of this calculation, about half of the fluoride exposure we need to account for is coming from water and half from other things, mainly dental products.
That's the gist of it, yeah. It really highlights how complex it is to assess risk for something we encounter in multiple ways. It's not just about the water level in isolation.
Right, it's the total picture. Okay, that sets the stage. Let's move on to one of the main health effects they looked at. Dental fluorosis. I think a lot of people have heard of this one. What exactly is it?
Yeah, dental fluorosis, as the panel discussed, is probably the most well-studied health effect related to ingesting fluoride. It's been looked at for decades.
And it's basically something happens to the tooth enamel.
Right. It's essentially a situation where the tooth enamel doesn't mineralize quite properly while the teeth are still developing under the gums. Hypomineralization is the technical term.
Hypomineralization.
Yeah.
So the enamel isn't as, I guess, dense or uniform as it should be. What does that actually look like on someone's teeth?
Exactly. And the appearance can really vary. It can range from very faint, chalky white lines or spots sometimes so subtle they're hard to see, even for a dentist,
Huh.
all the way up to more noticeable brownish stains or even tiny little pits in the enamel surface in cases where fluoride exposure was significantly higher during that critical tooth development window.
And I remember reading there are different levels or degrees of fluorosis. Could you walk us through those categories?
Sure. The panel often referred back to the classic work by H.T. Dean from way back in 1942. That study really laid the groundwork.
Wow, 1942, still relevant.
Very much so, especially for this. So Dean described a spectrum. You've got very mild fluorosis, which, like I said, can be super subtle. And importantly, at this level, there aren't really negative health effects. Some even suggest it might help prevent cavities, and it's generally not seen as a cosmetic issue.
Okay.
Then there's mild fluorosis, which is a bit more noticeable, but still usually not something people consider a cosmetic problem. But then you get to moderate fluorosis.
And that's different.
That's where you can start seeing more obvious, sometimes diffuse, staining. And this is where the panel drew a line, considering moderate fluorosis an undesirable aesthetic effect, making it relevant for their risk assessment.
An aesthetic effect. Okay, so the concern is more about appearance at that level?
Primarily, yes. Though very high fluoride levels can lead to severe fluorosis, which can involve pitting and might actually impact the tooth structure and function, but moderate was their focus.
Got it. So the panel decided that this moderate level, with its potential impact on appearance, was the key thing to focus on when setting guidelines.
Exactly. They agreed that moderate dental fluorosis should be their endpoint of concern. The reasoning was that the potential for noticeable staining at this level could impact someone's appearance and, possibly their psychological well-being because of that.
And it's interesting they're still leaning so heavily on that 1942 Dean study. Why rely on such old research? Wouldn't there be newer data?
That's a fair question. They acknowledged its age, definitely, but they also highlighted a really critical point. That study was conducted at a time when drinking water was practically the only significant source of fluoride exposure for most people.
Ah, okay. Before widespread fluoridated toothpaste and stuff.
Precisely. So that makes it a bit easier, or perhaps cleaner, to link the fluoride levels specifically in the water back then to the observed dental effects. It provides a clearer baseline, in a way, despite its age.
That makes sense. Now, they mentioned something called a point of departure. What does that term actually mean in this context?
Right, the point of departure, or POD. Think of it as a specific level of exposure in this case, a concentration in drinking water, where the scientists start to see a statistically meaningful increase in the health effect they're worried about.
So the point where the risk starts to measurably climb above the background level?
Basically, yes. For moderate dental fluorosis, the panel agreed on using what's called a benchmark dose, lower confidence limit specifically, the 1% level, or BMDL01. They calculated this from Dean's data to be 1.56 milligrams of fluoride per liter of drinking water.
1.56 milligl. So at that concentration in the water back then, they estimated about a 1% increase in moderate fluorosis starting to occur in that population.
That's the idea behind using the BMDL01 as the point of departure. It's a statistical starting point for the risk assessment.
Okay. And what about timing? When are kids most vulnerable to developing fluorosis? Is there a specific age window?
Yes, the panel identified the period from birth up to about age 4 as the time of greatest susceptibility for the permanent teeth overall.
Birth to 4.
But they particularly highlighted ages 1 to 3. That's when the enamel on the most visible permanent teeth, the upper front ones, the maxillary incisors, is developing.
Ah, the front teeth, right.
Exactly. They also noted that some other teeth, like the upper canines, continue developing up to around age 7. But importantly, they concluded that after about age 8, once the crowns of the permanent teeth are pretty much formed, the risk of developing dental fluorosis from fluoride ingestion is essentially gone.
Good to know. Okay, that covers fluorosis pretty well. Now let's shift to an area that seems to be getting a lot more attention lately. The potential connection between fluoride in drinking water and neurocognitive effects in children. What did the expert panel make of this? You mentioned our listener was quite interested here.
Yes, this is definitely a key area and one where the science is, well, let's say, rapidly evolving and quite complex. The panel absolutely acknowledged the growing body of research, including some studies suggesting a possible link between fluoride exposure from drinking water and slightly lower IQ scores in children.
Even at levels found in typical North American water systems.
Yes, some studies have suggested associations even at levels around or below the current Canadian guideline, which is part of why this review is happening. Health Canada itself had commissioned a systematic review that pointed to cognitive function, specifically potential IQ reduction, as a candidate endpoint to consider for setting that health-based value.
Okay. And I think I saw a mention of a report from the U.S. National Toxicology Program, the NTP. What was their take?
Right, the NTP report reviewed a large number of studies. They concluded, broadly, that the evidence for neurodevelopmental or cognitive effects in children seemed less consistent and less clear at fluoride exposures below 1.5 milligrams per liter compared to studies looking at higher concentrations often found in other parts of the world.
So more uncertainty at the lower levels relevant to Canada.
Generally, yes. And following their own look at the evidence, another group, Risk Sciences International, identified a provisional point of departure of 1.5 milligl for potential neurocognitive effects. But, and this is important, they also acknowledge that the actual level where concerns might begin could potentially be lower, especially based on some more recent analyses, including data from a Canadian birth cohort study.
It really sounds like there's, definitely something researchers are actively investigating. But what was the expert panel's final sort of bottom line on this potential link?
Okay, and this is probably one of the most crucial takeaways from their meeting regarding this topic. The expert panel reached a clear consensus that there is not a sufficient scientific basis at this time to recommend a specific point of departure and consequently a health-based value derived from potential neurocognitive effects.
Wow, okay. That's quite definitive, especially given all the noise around this issue. What was their reasoning for landing there?
They really emphasize the uncertainties. While several studies, particularly some recent cohort studies, have raised legitimate concerns, the panel felt there are still significant questions about whether the evidence definitively proves a cause and effect relationship between fluoride exposure at typical community levels and these neurocognitive outcomes.
So correlation isn't necessarily causation.
That's a big part of it. They also noted that less weight should probably be given to studies called ecological studies, which look at whole population averages and cross-sectional studies, which are just a snapshot in time.
Right.
They placed more weight on the few prospective cohort studies, the ones that followed groups of children over time, and measure both their individual fluoride exposure and their cognitive development. But even with those better designed studies, there were still inconsistencies and methodological questions that prevented the panel from feeling confident enough to set a specific number based on brain effects.
So the evidence just wasn't as solid or consistent as it was for, say, dental fluorosis.
Exactly. The link seemed less clear, especially at the lower exposure levels.
But they didn't just dismiss the possibility entirely, did they?
Oh, absolutely not. They were very clear on that. They strongly acknowledged that some studies do suggest potential adverse neurocognitive effects might occur at fluoride levels lower than those causing moderate dental fluorosis. They stressed that this possibility shouldn't be ignored.
So keep watching this space.
Definitely. They emphasized that the science here is moving fast, and new, high-quality studies need to be considered as they come out. But based only on the evidence reviewed at that meeting, they didn't feel they could pinpoint a reliable threshold for neurocognitive effects to base a guideline on. It's a tough spot acknowledging a potential risk, but lacking the certainty to quantify it for regulatory purposes.
Yeah, I can see the challenge. What kind of research did they suggest would actually help clear things up on this neurocognitive front? What do we need?
They laid out a pretty clear roadmap for future research. They stressed the need for more large, really well-designed longitudinal studies.
Following kids over time.
Yes, ideally starting from conception, following children right through childhood, and really focusing on those lower exposure ranges that are most relevant in places like Canada. These studies should also look at a wider variety of cognitive skills, not just IQ.
Makes sense.
And crucially, they need better ways to measure individual fluoride exposure from all sources, maybe using biomarkers like 24-hour urine collection, not just relying on tap water levels. Plus, being super careful to control for other things that can affect brain development.
Like what?
Things like exposure to lead or arsenic, nutritional status calcium, iodine intake socioeconomic factors, parental education. All those potential confounders need meticulous handling.
Right, isolating the fluoride effect, if there is one.
Exactly. And finally, they mentioned that understanding the actual biological mechanism, how fluoride might potentially affect brain cells or development, would be incredibly helpful for interpreting the results from these population studies.
So it sounds like the book is definitely not closed on the neurocognitive question, but we need much more robust, detailed, long-term research to get definitive answers.
That's a very good summary of their position, yes.
Okay, so let's shift gears then and talk about how the panel actually used all this information, the fluorosis data, the neurocognitive uncertainties, to think about setting that overall health-based value for fluoride in our drinking water.
Right. So as we've kind of established, both moderate dental fluorosis and potential neurocognitive effects were identified as the most sensitive potential health endpoints,
Right.
the ones likely to occur at the lowest exposure levels.
But they couldn't pin down a number for the neurocognitive effects.
Correct. Given those uncertainties we just discussed, especially about the shape of the exposure response curve at low concentrations, the panel concluded that moderate dental fluorosis was the more scientifically robust endpoint to use right now for deriving the health-based value.
Okay. And the point of departure for that, based on the Dean study, was 1.56 mg/L. So how did they get from that starting point to a recommended safe level in our actual drinking water? What's the math?
Well, typically in toxicology, you might calculate something called a tolerable daily intake, or TDI basically, how much someone could ingest daily over a lifetime without appreciable risk.
Uh-huh.
You usually get that by taking your point of departure, like an animal study result or a human observation level, and dividing it by uncertainty factors. These are like safety buckets.
Safety factors for what?
To account for things like differences between animals and humans, differences in sensitivity among humans, gaps in the data, the severity of the effect, things like that. But in this case, because their point of departure, that 1.56 mg/L, was already expressed as a concentration in drinking water from a human study.
Ah, okay.
They used a slightly more direct approach. They essentially proposed applying an uncertainty factor directly to that 1.56 mg/L drinking water concentration.
Okay, so it's like saying, we know 1.56 mg/L is where we start seeing a small effect, so we need to divide that by some safety factor to get to a level protective of sensitive people.
That's the basic idea for calculating a safe drinking water concentration. Yes, divide the point of departure, POD, by the chosen uncertainty factor, UF.
But wait, didn't we also talk about that allocation factor, the 0.5? Where does that come in?
Right. Good catch. So once you have that safe drinking water concentration, POD divided by UF, you then need to adjust it to get the final health-based value, HBV, for drinking water guideline purposes.
Yeah.
That's where the allocation factor comes in.
Okay.
The final health-based value is that calculated drinking water concentration multiplied by the allocation factor. So HBV, POD, UF, EGAF. This step accounts for the fact that drinking water is only part of the total fluoride exposure.
Right, because of the toothpaste and other sources. So you apply the safety factor first, then account for the other sources.
Okay.
So what were the key pieces that the panel actually agreed on for doing this calculation?
They nailed down several key components they agreed on. 1, moderate dental fluorosis is the key health effect.
Okay.
2, using Dean's 1942 study as the key study for this effect.
Right.
3, a point of departure of 1.56 mg/L based on that study.
Got it.
4, that there is a definite need for an uncertainty factor, specifically to account for the database deficiency. The remaining questions around...
So the uncertainty factor wasn't just for fluorosis, but also for the neuro issue.
That was their explicit reasoning for needing one, yes,
Yeah.
to be protective, given those lingering neurocognitive concerns.
Interesting. What else?
5, they agree that young children, specifically the 0-4 year age group, are the most sensitive subpopulation to protect.
Makes sense, given tooth development.
And 6, they agreed on using that allocation factor of 0.5 for this 0-4 year age group.
Okay, that sounds like they really hammered out most of the framework for the calculation. So
Yeah.
what was the final health-based value they recommended? What number did they land on for the UF?
And here's the kicker. The panel did not reach a consensus on the specific numeric value of that uncertainty factor.
Wait, really? They agreed they needed one because of the neurocognitive uncertainty, but couldn't agree on how big it should be.
Exactly. They all agreed an uncertainty factor should be applied, but they couldn't settle on whether it should be, say, a factor of 2 or 3 or 5 or 10 or something else. They ultimately decided to leave the final decision on the size of that uncertainty factor up to Health Canada.
Wow. So they laid out the whole scientific equation. POD is 1.56, AF is zero point 0.5, use moderate fluorosis, protect kids 0-4, and definitely apply a UF for neurocognitive uncertainty, but then couldn't agree on the UF number itself.
That's correct. It really highlights just how significant those uncertainties around the neurocognitive effects were in their deliberations and how difficult it was to quantify that uncertainty into a specific safety factor that everyone could agree on.
That seems like a really critical piece left undecided by the scientific experts. It puts a lot on Health Canada's plate now.
It certainly does. It underscores that tension between the more established, visible effects like fluorosis and the less certain but potentially more concerning effects like neurocognitive changes. Regulators often face these situations where the science isn't perfectly clear-cut.
Okay, so just to sum all this up then, the expert panel really zeroed in on moderate dental fluorosis as the most solid scientific basis for their recommendations right now.
Yes.
They pinpointed that 1.56 milligl level from the old Dean study as the starting point where that effect becomes noticeable.
The point of departure, yep.
They factored in that we get fluoride from things other than water using that 0.5 allocation factor.
All right.
And significantly, they acknowledged the ongoing concerns and scientific gaps regarding potential effects on brain development, concluding that a specific safety factor and uncertainty factor must be included because of this.
But they couldn't agree on exactly how large that safety factor should be.
Right, so they passed that specific decision back to Health Canada.
That's a good summary of the key scientific outcomes of the panel's discussion. They provided Health Canada with a clear scientific framework and highlighted the crucial elements to consider.
So what is the next step in this whole process? What happens now with these recommendations or lack of consensus on the UF?
Well, Health Canada will now take all this scientific input from the expert panel, the agreements and the point of disagreement on the UF, and they'll weigh it alongside other important considerations.
Like what kind of things?
Things like the technical feasibility of treating water to different levels, the costs involved, analytical methods, maybe socioeconomic factors, and of course, they'll also consider the potential benefits of fluoride, even though this panel didn't evaluate that. It's a broader risk management decision now.
Okay, so the science is one piece, but now policy and practicalities come into play as Health Canada works towards potentially developing a revised guideline for fluoride in drinking water.
Exactly. The panel provides the scientific assessment. Health Canada makes the final guideline decision.
So as we wrap up this deep dive into the expert panel's meeting, it really just, I think, underscores how carefully even something as seemingly settled as fluoride in tap water is being scrutinized and reevaluated based on evolving science.
It absolutely does.
And, given the ongoing research that the panel highlighted and their own acknowledged uncertainty, especially around those potential neurocognitive effects, it really leaves you, the listener, with something to think about.
Yeah.
What further questions does this raise for you about how we as a society strike that balance between any potential benefits and the possible risks of fluoride in our water?